Black holes are weird, but could there actually be something besides a singularity in their core? There is a lot of interesting theories about black holes and what happens inside of them. The notion that once matter enters the event horizon, around the singularity nothing, not even photons themselves, can escape is one idea. Traditionally, we have thought that within black holes, all matter the black hole consumes is compressed into a tiny, infinitely dense point, a singularity. Because the curvature of space-time within the infinity dense point also becomes infinite, we cannot know what happens inside of a singularity. Some ways to explain what happens even seem to contradict some universal laws. In fact, when we try to model a singularity, the math tends to break down, which can lead to some wild results. However, although it may seem like black holes should not be able to exist, it's sort of illogical that matter can collapse down to infinitely tiny point. They are mathematically compatible with certain theoretical models of the universe. Many physicists through the years have come up with different theories that argue with the idea that the math is consistent or that a singularity could exist at all. One such theory replaces a singularity with something beyond strange known as Planck star, or sometimes called a dark star. To understand a Planck star, we must first understand something called Planck length. In the most basic terms, Planck length is the smallest possible unit of measurements. How small it is? It is approximately equal to 1.6 into 10 raised to minus 35 meter. In other words, it's about 10 raised to minus 20 times the size of proton, one of the smallest particles in existence. So it's very tiny. Since those numbers are hard to wrap your mind around, let's compare to something we can perceive with our own eyes, such as single strand of hair. The strand of hair is more comparable in size to the observable universe than it is to a single Planck length. In the theory, the Planck star is a theorized compact, exotic star that exists within a black hole's event horizon and is created when the energy density of a collapsing star reaches the Planck density. Planck density is the Planck mass, believed to the smallest black hole possible, divided by Planck volume, which is approximately 5.1 into 10 raised to 96 gram per centimeter cube. In a Planck star, the matter is compressed down to the smallest possible scale, the Planck length. If a black hole harbored a Planck star in its core, the matter would not be compressed infinitely, but would actually have small or tiny amount of volume, therefore eliminating the tricky singularity. Overall, the Planck stars are interesting but complicated ideas about the ways in which the black holes may work. So let the astronomers decide whether they are viable replacement to the singularity theorem or not.